So in terms of navigating through the program, which has been carefully designed, we are now at the point where we introduce education as a theme, and looking at education as a way to navigate and to face the challenges that we were discussing yesterday. What kind of education do we need, especially engineering education, to meet these challenges? And what could we learn from some of the best brains around who have been working on improving the education system? Our first speaker is a great person to have here today.
Especially because she has worked with MIT on the next generation in engineering education and has 20 years experience as education consultant. Ruth Graham. The floor is yours.
Thank you.
And you see the time there?
Great. Lovely. Thank you. Well, thank you. It's a great pleasure to be here today. I'm talking about the changing face of global engineering education. And it's a really interesting time to be speaking to you about this topic because the engineering sector really is at a tipping point. We're entering a time of really quite rapid change in engineering education. After 3 or 4 decades of discussion about the need to change engineering education, the need to nurture engineering graduates who are equipped to solve the challenging problems facing the world in the 21st century, graduates who are problem solvers, who are systems thinkers, who can work collaboratively across cultures, across teams, across disciplines. These are all themes that have been discussed across the engineering community for decades, but really very little change has happened until now. And this is something that I'm incredibly excited to see. And really it's something that I've only seen over the past 5 years, probably 2 or 3 years, where we've seen some really rapid change. Just to give you a little bit of context, engineering education across the world, obviously it looks slightly different in different contexts and countries, but by and large it's been quite a similar model across the world. It's been almost exclusively focused on maths and science. Most of the pedagogy is teacher-centered. Labs, tutorial sheets, for those of us that went through engineering education or have taught in universities, that's quite familiar. Projects and problems maybe in the first year, maybe a capstone design project. But a lot of the models, as I say, are very similar. I remember as an undergraduate engineer, 26 years ago, when Boeing published their 10 desired attributes of an engineering graduate. I was really interested in this because I was an engineering undergraduate, but also because I wanted to move into aerospace on graduation. And I was really interested to see, what is it that industry is looking for in engineering graduates? And it was clear to me that my studies, my education to date had really equipped me for the first 2 of those attributes. A good understanding in engineering fundamentals and a good understanding in design and manufacturing. But for these other aspects, multidisciplinary perspective, an understanding of the context of engineering, communication, ethical standards, ability to think critically and creatively, flexibility, curiosity, and a profound understanding of the importance of teamwork. These were things that I couldn't really put a finger on where I learnt those in my undergraduate education. And as I moved on to teach engineering to undergraduates, equally, it was clear really where we were teaching the fundamentals of engineering, the fundamental engineering sciences. But for the rest, really, they were just listed as learning outcomes or attached to 1 or 2 projects. And we would say, okay, so we'll do all of this in a final capstone project. But it wasn't really integrated in a coherent way across the curriculum. And that is what I'm seeing huge change in, and really very recent change across the world. So in the talk today, I wanted to talk about 3 things. Firstly, why are these changes happening now? Secondly, who are the current and emerging leaders in the field and what changes are they making? And finally, what are the future challenges and directions facing the sector? So looking at why are these changes happening now? Why have we talked about this so long, but change is only happening now? I think there are a number of reasons. One is that industry, professional bodies and students are becoming much more vocal about the need for change. And in turn, universities are responding to that. I think recognizing the challenges facing engineering graduates and facing society and the planet. A lot of engineering programs are really, and deans of engineering are really addressing this issue head on and looking to make fundamental change. The second is, I think, a growing body of evidence that this isn't a zero-sum game, that developing some of these other skills and attributes in students doesn't mean that you sideline the technical side, the engineering fundamentals. I'll give you one very brief example of some of the evidence that I think has been quite effective in the sector. One is from Denmark. There was a survey of Danish employers looking at their perceptions of the graduates from two universities. One, Aalborg University, which is a problem-based institution, delivers all its education through problem-based learning, and DTU, which at the time was a more traditional engineering program. And they asked, what is the skill set of the graduates coming to you from these institutions? And you can see here, this is for the graduates from DTU. They pointed to high skills in terms of the quality of engineering and technical learning and knowledge. But for the others, perhaps lower, that the students would, or the graduates would score lower. But then if you compared them to the perceptions of the Aalborg graduates, where they achieved the same level technically, they were perceived to have much stronger personal and professional skills, working with industry, innovation and creativity, knowledge of business life and economy. So I think this kind of information and data really is starting to have an impact. The third driver, and I see this as a very significant driver, is governments calling for investment in the technology innovation pipeline. Governments seeing engineering schools and programs as an incubator for the talent that will underpin a technology-driven economy. And in the last 5 years, the investment by governments in engineering education to produce these future technology leaders and innovators has been very, very significant. I'll give you just one example here from Chile. Corfo, which interestingly is the Ministry of Finance, not the Ministry of Education, but the Ministry of Finance, has already invested over $200 million in selected engineering schools in Chile. A lot of that money is going into educational reform and to instilling and developing entrepreneurial talent, critical thinking and problem solving amongst Chilean undergraduates. And they move from a very traditional engineering, very long and traditional engineering programs to something very, very different. And I think the fourth reason is competition. As institutions start to make change, I think a lot of universities are recognizing that they can't stand still. And when you have institutions like UCL in the UK, like MIT in the US, making systemic and fundamental change to how they educate their engineers, other universities are really taking notice and starting to think about fundamental change. So the second question is, who are these institutions? Which are these institutions that are seen to be current and future leaders in the field? So I was commissioned by MIT, who were looking and are making some quite radical changes to the curriculum to look at the global state of the art in engineering education. And as part of that study, I interviewed almost 200 thought leaders and practitioners in engineering education from across the world, from 21 countries across the world, to understand their perceptions on what does best practice look like, where is the sector going, what kind of challenges are you facing in terms of delivering the best possible engineering undergraduate education. And one of the questions that I asked the group of thought leaders was, which institutions do you identify as the current leaders in engineering education? Which institutions do you think are currently leading the way? And I pulled together all of their recommendations and put it together in a rough ranking. And these were the 10 institutions that were identified. And I think the names of those institutions are probably quite familiar, perhaps with the exception of Olin College, which is a relatively new, small, very innovative university in Massachusetts, just outside Boston. But I think the rest, MIT, Stanford, Aalborg, Delft, UCL, Purdue, NUS, Cambridge, and Chalmers, are all quite well-recognized institutions in engineering. And then the next question I asked was, which institutions do you consider to be the emerging leaders in engineering education that will define best practice in a decade? And these were the institutions that were most often identified. A very different list and a really interesting list. I should say that this report is all available online. I'm happy to give you URL details, but all of this data and the full report is available online. So, as I say, a list, and I think a lot of these institutions are much less familiar. So SUTD in Singapore is a new institution established in 2012. Iron Range Program was established at a similar time. Charles Sturt University in Australia was, again, is a New Start program. So these are some quite different names of institutions that are all doing some very interesting and different things in engineering education. And just looking, what distinguishes this list of current leaders from the list of emerging leaders? So if you look at that list of current leaders, most have maintained a relatively traditional curricular structure and content, although a number of those universities, such as MIT, since are making some quite big changes. Some of the experiences, courses are focused on attitudes and mindsets, but it's localized. It's just individual courses rather than embedded throughout the curriculum. There's an emphasis on aspects such as user-centered design, hands-on experiential learning, online and blended learning, and experiences in creativity, innovation, and entrepreneurship. And these institutions generally have quite a traditional gender balance, so women make up around 15 or 20% of the undergraduate student cohort. And if you look at the list of emerging leaders, what are the common threads that link those institutions? Most of them, so of the top 10 that I showed you, 7 have either completely reformed their curriculum from the bottom up or their new starts. So these are very different sorts of engineering programs with a very different underpinning structure. There's a strong focus on online work-based learning, multidisciplinary and experiential open-ended problem solving, looking at critical thinking, creativity, and entrepreneurship, a very strong emphasis on sustainable development. One thing that's very interesting is a lot of these programs were shaped by regional need or constraint, allowing them to take a much more visionary approach. So one example is the Pontifical Catholic University of Chile that really has been spurred by this drive to develop more technology entrepreneurs within the country. Arizona State really has been driven by a drive to support the needs of the state of Arizona. So there's a real clarity to the vision, the educational vision within many of these institutions. And I'll give you one example of an institution that is considered to be an emerging leader. And this is UCL in the UK, and it's a university that I've worked quite a lot with. Obviously, they had an existing engineering program at UCL, but a number of years ago, that program was radically reformed, and it really is very different now. There's a much stronger focus on multidisciplinary learning, so student cohorts working together across the engineering disciplines. Throughout the first 2 years of study, it's broken up into 5-week cycles. So in the first 4 weeks, the students learn the engineering knowledge, skills that they need to apply for a weeks-long project in the final of those 5 weeks called a scenario. It's a very intensive project, but they're drawing on the knowledge that they've learned in those first 4 weeks. So they can really contextualize what they're learning, but also develop different skill sets around that. So this new program, the Integrated Engineering Program in the UK, really has been quite a radical departure and really is sending out ripples, I think, certainly across the UK in terms of what engineering programs might look like. So the final question is, what are the future directions and challenges facing the sector? And this is something that was looked at specifically in the MIT report, but this is also something that I have seen through my work with universities across the world seeking to make systemic educational change. The first, and one that I've found really interesting and very striking, is a tilting of the global axis in engineering education. from north to south and from high-income countries to the emerging economic powerhouses in Asia and South America. So when I asked the question, which institutions do you consider to be current leaders in engineering education, and took all of those institutions identified together and marked them by country, the locations of those current leaders was predominantly in North America and Europe. So over 80% of the recommendations people made for current leaders in engineering education were in North America and Europe, very few in Asia and South America. But then if you look at the countries of institutions that were identified as emerging leaders in engineering education, quite a different picture emerges. Only 50% were from North America and Europe. Almost a third were from Asia, and over 10% were from South America. So this is a very different picture, and this is something that was a very strong theme of the feedback from thought leaders, is that actually the emerging leaders are coming from all parts of the world, and perhaps parts of the world that aren't necessarily at the moment considered to be current leaders in engineering education. And what interested people particularly wasn't necessarily where these institutions are now, but it's the trajectory and speed of travel of those institutions, the level of investment and the focus that they have on educational change, and a real sense that if you go 1 or 2 decades down the line, institutions from South America and Asia really are going to be amongst those leading the world in terms of engineering education innovation. The second theme in terms of where engineering education is moving towards is the educational focus of future leaders. There were 4 themes that came through very strongly in terms of what are these emerging leaders going to be doing? What is the next generation of engineering programs going to be focusing on? Of course, in addition to the technical fundamentals, to the core engineering sciences. The first was student choice and flexibility, that there wouldn't be a single pathway that all students would take through their programs, that programs would very much be individualized, and students would take different pathways depending on their interests and the opportunities available to them. The second was multidisciplinary learning, that you wouldn't just be, so I was educated as a mechanical engineer, that you wouldn't just be educated within your silo, that you actually would be educated across the disciplines and really understand how your discipline fits within the engineering and the wider societal context and what kind of impact that you'll make within your discipline. The third was the roles, responsibilities of ethics of engineers in society. And this really is a very strong theme within many of the programs that I've looked at and many of the programs of educational change that I'm working with, that looking at what kind of impact the ethics, the impact of the decisions made by engineers, and a really much stronger focus on the societal context for engineering problem solving and decision making. And finally, global outlooks and experiences, looking beyond the borders of the country that you're educated in to be able to understand the national context for your career, but actually looking beyond your own borders for part of your education. So those were the 4 of the key attributes, I think, of future engineering programs that perhaps would distinguish them from the programs that we see today. And just to give you a case study from SUTD in Singapore, Singapore University of Technology and Design. This is a university that was established in 2012 in collaboration with MIT. It establishes a very different kind of education and really demonstrating, I think, a lot of these attributes that I was pointing to. So, for example, there are no traditional disciplinary boundaries across the institution as a whole. All students are educated as a cohort in the first year, and when they specialize, it's in cross-disciplinary areas, such as engineering systems and design. In their education, there's 2 18-week periods for internships or exchanges. So there's a very strong focus on students leaving the institution, working with industry, working abroad. And they also have a really interesting educational approach. They call it the 4D approach, the D being design, but really underpinning the education with design experiences for the students. So design practices within each course so students can understand the fundamentals of whatever topic they're looking at. Projects that span between courses. So in one semester, a student would study a series of very different subjects from within and outside engineering, but have projects that link all of those so that they can apply the knowledge that they've learned and the skills that they've learned across those projects. And also projects between year groups so that students can understand how they're building their knowledge and skills and attitudes throughout the 4 years of their learning. So really immersive in design as well. And the third theme, I think, that will be really critical to the next generation of engineering programs will be scaling up and integrating good practice. That if we look at an institution that was mentioned a lot in the study was Olin College. A lot of people look to Olin College for inspiration. It's an experiential approach, very student-centered, very project-centered, and very immersive for the students. But they only have 350 students in the whole institution, 85 in each year group. The question is, how do you scale that up? How do you produce that kind of education, that kind of quality of education, when you're not talking about 85 students, but you're talking about 1,000 students or more? And large cohort sizes, how do you provide individual pathways for students to really build on their own strengths and weaknesses, to make their own choices through their education? And I think that will be a major challenge and a major focus of activity over the next decade or two, is how do you make that a reality for most public institutions when you're delivering this kind of education at scale? And what a lot of people talked about is the power of putting the content of the curriculum online and saving the face-to-face on-campus experiences for project-based and experiential learning. And that was a major theme from a lot of the thought leaders as to where engineering education may go in the future, particularly for large scale. So I'll give you one example of this. This is from Charles Sturt University in Australia, a university that I hadn't come across up until 2 or 3 years ago. They've established this new program just 3 years ago, which does just that. There's a strong focus on work-based learning, so students spend a significant amount of their education within industry, in internships, learning through practice. But they've put the whole content, the whole curriculum content online, and the rest of the on-campus face-to-face activity is structured around a series of projects that become more and more complex and ill-defined as they move through their studies. And they are asked to identify themselves what is the content that I need to master in order to solve these problems. And what they've created is something they call the topic tree. So they've disaggregated all engineering concepts and skills into discrete 3-hour topics that the students must identify and master. By the end of their education, they must have completed 600 topics and a certain number before they go on their first placement. Around a quarter of those topics are mandatory. All students must master them. But for the rest, it's really based on the interests and the problems that the students need to solve, and really puts them in charge of their learning. And I guess for me, as an educator in engineering, I think this topic tree really provides an interesting visual of the relationships and dependencies between topics, so students can really understand where each set of knowledge and skills fits within the broader engineering discipline. And I think this approach, although at Charles Sturt at the moment it's very small scale and still quite experimental, a lot of people in engineering education are watching this with great interest, looking at the kind of material that's on this topic tree, how it's presented and the platform that's used, and how students are interacting with that and using that, and thinking about how something like this can be translated to a much larger scale within their own institutions. And just finally, the MIT study, and again with the work that I've looked at in terms of educational change, identified 4 key challenges to change across the sector. And this was really common across all of the institutions that I've spoken to. The first, I think, is probably the most critical, which is the reward and recognition systems. There hasn't been a single project that I've worked on, particularly where I'm interviewing faculty, where this issue hasn't come up again and again. What are the incentive structures within the institution? And to what extent are faculty incentivized to spend time, energy, and expertise on engineering education versus research? And to what extent do systems within universities incentivize people to focus on innovation in engineering education, in education? And this is something, again, where there is a huge change. Just in the last, I would say, 2 or 3 years, a significant number of universities are now working to change their promotion systems and their appointment systems such that teaching is a prominent part of that, and focusing on education won't be an impediment to career advancement in universities. And actually, a number of countries like the Netherlands are also looking at systemic change across the sector. A second challenge is the alignment of goals between government and higher education. Attention, what are the goals of higher education, accreditation, the unpredictable nature of government funding? That's a tension that many countries and institutions really struggle with. A third is, as I mentioned before, adapting to larger and more diverse student cohorts. This is something that universities across the world are struggling with. Student cohorts in engineering very often are getting larger and more diverse. How do you provide an education that meets the needs of all of the students that you're welcoming, and across a large cohort? And finally, disciplinary and educational silos. How do you create an educational experience that is truly multidisciplinary, that allows students to see the wider context of the problems they're solving, when most universities are structured around very siloed disciplines within engineering? And how do you accommodate that, the need for multidisciplinary learning, when you're actually, the cost centers of the university are very siloed? So, in conclusion, engineering education is changing, and changing rapidly. I think the next 10 years is going to be really exciting to see what kind of changes happen across the sector. The new models are, in addition to technical knowledge, seeking to nurture skills, mindsets, innovation, creativity, a much more diverse range of capabilities of engineering graduates. The influence of such approaches are really now emerging, and you can see them in many programs across the world. And another change that's happening in parallel with that is significant changes to the reward and recognition system. And I think as those 2 changes happen in parallel, and if those 2 changes happen in parallel, I think it can be a huge vehicle for quite major sector-wide transformation. So thank you.
Thank you for showing us and persuading us that change is really taking place. But going back to your first slide, showing the increasing requirements in the field of education of engineers, is there a risk that you add on and overload the curriculum at the expense of the necessary basic skills?
Yes, absolutely.
And how are these universities that you showed us aware of this, and how are they handling it?
Absolutely. I mean, universities are acutely aware of this. And within institution, one of the biggest barriers is this concern of kind of dumbing down, that we're going to be dumbing down our curriculum in order to try to integrate some of these other attributes. And it's something I think that has to be very carefully monitored. Certainly of the institutions that are making the changes, they're looking very carefully to make sure that those students are still maintaining the same levels in terms of the technical understanding of the engineering fundamentals. But it is a balance, and I think it's something that a change that has to happen very carefully. And one danger is, of course, that you say, well, we'll just add to the curriculum. We'll keep everything as it is, and we'll just add, and students will become overloaded. So it is a careful balance, and I think that's one of the most difficult aspects. But I think one of the things that that universities are often looking at is, do we need some of this stuff? Do we really need students to master all of these things in order to graduate? And actually go back to the curriculum and say, oh, which of these are absolutely critical for our students and which are optional? And I think very often engineering programs are just added to. People very often don't stand back and say, well, what do we have here? And do engineers of the 21st century need all of this?
Is this changing education geared to the present or immediate future labor market?
It is, yes. I mean, I think that's one of the major drivers within, and these calls for change from industry, is
So how can we educate the future leaders then? How will we be able to educate the future leaders?
Leaders who are going to be working
the game changers.
Okay, so do you mean people coming back who've already graduated?
If I have to explain, if the education system is geared to the present labor market,
oh, I see.
We'll go on and go on and go on. You'll perpetuate a situation.
I mean, I think it's being driven in part by calls for change from industry, but I think people are very much looking to, where are our graduates going, and actually saying, we don't know, that I think the jobs that a lot of engineering graduates, people being educated now, we don't even necessarily know where their careers will be and what kind of problems they'll be solving. So I think that flexibility is a huge part of it, instilling in graduates, in engineering students, that ability to adapt to different needs and different problems. And I think that's really fundamental to what a lot of the changes that are coming through.
The ability to learn and unlearn, basically, for the students, to train that capability.
And I think the ability to identify the problem that you need to solve, that you're not just going through the motions of solving a problem that someone's given you, but you're actually identifying the problem first. And I think that's critical because current generations of graduates won't be doing one job through their career. They'll be doing a series of different jobs and actually problem solving, identifying the problems as well as solving them.
Can I ask you, when you've studied these more progressive programs or institutions, who has been involved in shaping the change? Have you seen examples that we could learn from in terms of who the important people have been on the teams?
It's interesting. I mean, for a lot of those institutions, there's a wide range of stakeholders. They're bringing in students and faculty and university leaders, but also bringing in graduates. What has most benefited you in your career from the education that you had at the institution, bringing in industry, bringing in regional entrepreneurs. So I think it's been a very wide net, actually, and listening to all voices about what's needed. And actually, I think using that consultation to also create collaboration across and beyond the institution that will not only inform what changes are made, but actually will be part of that education to a much greater extent than they have been in the past.
Can you also reflect a bit on the leadership you've seen, the leadership required to change? Because some of these institutions are hundreds of years old. People are very proud of what they're doing. Faculty, they know their stuff, but still we need to change to adapt. What kind of leadership is needed to actually create that vision of where we're going forward and then adapting to that without too much disruption internally?
I think that the leaders that I've seen have a number of qualities. I mean, they're visionary. They understand the constraints of the institution, so they know the constraints that faculty are under. They know that change isn't easy. And very often they're individuals actually who have a leadership position who are known for both their teaching and their research. Very often it's a dean he's known to have a strong track record in research, but also a strong commitment to the students, who is well respected by the faculty population. So I think there are a number of leadership qualities, but I think gaining the trust of faculty is absolutely critical. And I think ensuring that they understand that they're not going to be overly burdened by the change, and that this is part of a collaboration. And actually that the reward and recognition systems the leadership will recognize the kind of contributions they've made and their time and effort, and that will be rewarded should they wish to go for promotion. So I think all of those pieces together are really important in leadership, because there are a number of changes that have been attempted and have failed, and I think there's an awful lot to be learned from people who've made successful change.
Do we have time for one more question?
No. Can I ask the audience?
Absolutely, yeah.
Were you inspired by this? Hand up.
More.
And did you learn something very straightforward that you hadn't been thinking about before? Yes, almost half of the people in the audience are saying that. See how worthwhile it was that you came and joined us.
Thank you.
Thank you so much.
Thank you.
A number of people were inspired by your talk, but don't tell them.